Hello everyone, and here we start with Chapter 3 in Linear Algebra. We are experimenting here with flipping the classroom, which means I'm going to record these videos, you will watch them, take notes on them, and then during class time you can work on assignments, come to me and ask for help with questions on things, and I'll check off on a checklist I'm going to give you of what your responsibility is and at what date we will take the test on this chapter. This one's a good one to start this with because it's pretty straightforward. The chapter is not too long, and I think it's one that can be done pretty self-paced and self-guided. So take out your notes. Again, you can pause and like rewind or rewatch the videos at any point, and we'll get started. So at the heading of your notes for the first section here, write 3-1, graphing and writing inequalities. Well, first I guess we need to actually talk about what an inequality is. So using your fabulous grammar skills in knowing what this prefix in means, which is not, basically it means something that's not going to be equal. And what we specifically define it as in math is that it's some kind of statement or a sentence, and basically it's going to be that two of our quantities are not equal to each other. Okay, two quantities that aren't equal to each other. Now, we've talked all in the first half of Chapter 2 about equations, and that an equation is a sentence and it has to have an equal sign. So when we get into Chapter 3 here, you're going to see things that basically look a lot like the equations and the solving that we did, but we're not going to have an equal sign. We're going to have inequality signs, and there's more than one. And you've seen these before. We just kind of need to revisit what they mean. So the first one we'll talk about is this guy. I know that you probably have used different kind of I don't know, examples thinking about the alligator chomping or something like that with the open mouth. This is the less than symbol. Typically what we do is we read left to right. The pointy end is always pointing toward the smaller item and the open end is the larger one. So there's less than. And its counterpart would be the one facing the other way, which is greater than. But there are more. And here's the little tweaks that we put on here. So you have less than and greater than. Then we have this one, which means, again, less than, but it also combines with it an equal sign by putting that horizontal bar underneath. So this one means it could be less than or it could be equal to. Either case, it does not have to satisfy both of them at the same time. And likewise, you have the same situation with greater than or equal to. And again, it obviously can't satisfy both things at the same time. That's why we use the word or. Greater than or equal to. So you have less than, greater than, less than or equal to, greater than or equal to. And we do have one last one. See, the bells are ringing just like you were here. The last one is simply not equal to. So there really are a total of 5 different inequality symbols or inequality signs that you will see. And now we'll put those to practice here. I'd like you to make 4 columns in your notes here. One that says algebra. The next one that says solutions. Then the third column here can be words, and the last one is graph. All right, so what we're going to do is put in some situations and then describe what's happening excuse me, in each of these 4 kind of ways to represent it. So for example, let's just start very simple and straightforward. In algebra, if I write this inequality, x is greater than 3. Now, if I told you start brainstorming solutions to numbers or values that mean x is greater than 3, well, you'd say, well, 4 works. And I would say, yes, and there's more. 5 and 6 and 7. I could even choose something like 3.1. Or if I wanted to get super fancy, I could say something like pi. Ooh, pi is greater than 3. I could choose a number like 1,000,000, for goodness sakes. And the problem is, there's so many solutions, there's no way I could write them all. In words, I could simply write it this way. Any number greater than or larger than 3. Because obviously I can't list them all, because there's so many. There's an infinite number of solutions here. And so in words, I would just probably write it this way. I'm going to cheat and use the number 3 instead of writing out the letters there. But frankly, I think the best way that you can describe all of the solutions to this algebraic inequality is to graph it. You've heard that old expression that a picture's worth 1,000 words? Well, here we go. All right, if I draw a number line here, and when I draw my number lines, I'm going to always ask you to show me where 0 is. 1, 2. Here's 3. 3 is my significant or my important piece of information here, because I'm basing all of my data or my solutions with reference to 3. Now, here's what's happening. I want all of these numbers like 4, 5, 6, 7, 3.1, pi, 1,000,000. I want that represented on here. So although I can't choose exactly 3, 3 isn't bigger than 3, but I want to show that this is my starting point. So what I'm going to do is put an open circle at 3, and then, because there's no way I could ever show you all of the numbers bigger than 3, we color in the number line to the right, and I make my arrowhead large, and I color in the arrowhead to indicate that, you know what, I can't include 3, but I can include every single solitary number to the right of 3, larger than 3, and I color in the arrow to indicate that this goes on forever. All right, let's try another one. So you can just put a squiggle on your columns here. I'm going to get a clean screen. All right, what if I say x is less than or equal to 5? Something like that. Well, here again, we could start listing numbers that are less than 5. 4, 3, 2. I could say -10, 0. I should make sure that that doesn't look like a 20. I'll put a 0 there. I could say -4.927. You know, you can pick any random thing you want. I could even say something like 4.99, because that's less than or equal to 5. And guess what? 5 is actually a solution to this inequality, because if I substituted 5 in for x, 5 is not less than 5, but it is equal to 5, so therefore it works. In words, we could simply write this: any number less than or equal to 5. Less than or equal to 5. However, that gets kind of cumbersome. You know, I've told you math people are, well, I don't want to say lazy, but they certainly like to be efficient with their time and their energy, which is why we're going to usually resort to the graph to illustrate what on earth we mean here. It's going to be so much more concise, compact, and complete if we do it this way. All right, my significant number with reference to this situation in this graph is going to be the number 5. I always want you to show me where 0 is. 1, 2, 3, 4. All right, and here's 5 up here. Okay, so this time I am going to indicate that actually 5 is a solution. So you're going to again put a circle right on the line at 0, or at 5 I should say, but this time I want you to color it in. You color it in because 5 is included. Do you remember last time? Last time 3 was not included and not a solution. That's why we left it open. But this time 5 is a solution, so we're going to color it in. This time I want numbers like 4 and 3 and 2 and 0 and all of this business in negative land. What we're going to do this time is simply color in all of the values that are smaller than or less than 5, which means you shade to the left, make a big fat line, and because I'm including everything to infinity, you're going to color in the arrowhead, make it super big, and color it in. Notice that I'm doing this exactly on the number line. I'm not doing things above the number line. I want you to put it exactly on the number line. Okay, now, how does this get put to use in some situations here? Well, it's not going to be as straightforward and as simple as just giving you a value. Of course, we're going to put some sort of order of operations and have you do some computation. So jot down this one. X is greater than or equal to 14 minus 3 squared. Remember, order of operations says do 3 squared first because that's an exponent. 14 minus 9 is exactly 5. So here's what I've gotten so far. This is my simplified or solved inequality. X is greater than or equal to 5. Then on all of these, I'm going to ask you to graph it because it's not just the number 5. It's more solutions than that. Every single one of these inequalities has an infinite number of solutions. Here's 0. 1, 2, 3, 4. 5 is going to be to the right over here somewhere. Put a circle here. And then because I have the equal sign, I'm going to color in the circle at 5, shade to the right. Okay, fill in the arrowhead to indicate I'm including all of the values to the right to infinity. There you go. Look at one more example here. 2 squared minus 6 is greater than or equal to W. Okie dokie. Use your order of operations to simplify this. 4 minus 6, well, that's negative 2. Greater than or equal to. Now here's my variable. Now technically, yes, you've solved this. However, when my variable is on the right-hand side of the inequality, it gets a little tricky. Right now I'm saying that negative 2 is greater than or equal to any of my values here. Now if you start thinking about this, I'm saying negative 2 is bigger than or equal to all these values here. That means W has to actually be smaller than, see the pointy end is pointing toward W? W is smaller than or equal to negative 2. You kind of have to read it backwards. In fact, for me, I have difficulty reading backwards this way, so I rewrite it, and I know that my inequality has to be pointing with the small tip at the W, and I basically read it backwards or rewrite it in the way that I can read it with the variable on the left. To me, this makes more sense. I can say W is less than or equal to negative 2, and when I go to graph this, I'm thinking, oh, yes, yes, yes. I want numbers like negative 3, negative 4, negative 5, and so on. Okay. Another way to always check yourself and to see if you're making sense is simply plug in 0 and see if 0 should be graphed or not. You know, when you look up here and I say, hey, is 0 a solution here? If I plugged 0 in right there, would that make sense? Is negative 2 greater than or equal to 0? No. 0 should not be graphed, and we'll find this out when you go to decide which way you're going to shade. Negative 2 is my significant digit. I have the equal sign part of my inequality, so I'm going to color it in. And I want numbers that are smaller than negative 2. In other words, negative 2 has to be bigger than all of my solutions, which is why you shade to the left. 0, 0 can't be shaded. 0 is not a number that negative 2 is bigger than. Or if you put it in here, 0 is not less than or equal to negative 2. I got to shade this way. In fact, I always like to rewrite ones where the variable ends up on the other side so that I can make sense of it and shade it the right way. Okay, now just put your pencil down for a second and look at this one. You should be able to now look at the graph and come up with an inequality. All right, now I don't have any variable necessarily indicated here, so you can choose whatever letter you want. X, Y, Z. You know, they always use X all the time, so I like to choose something else. I'm going to use V today. And here's what's going on. My significant digit here is at 2, positive 2. I see that it's an open circle, so I know that I'm only going to have a less than or equal sign, less than or greater than sign, no equal sign. Because I'm shading to the left, it's a less than. You can tell that because notice how this arrow matches that arrowhead. Oh, that's cool. This translates to this. I want all solutions that are less than 2. Let's look at another one. All right, write the inequality shown by this graph. Use whatever variable you want. I think I'll use W this time. My significant value here, where everything is starting, is at a negative 5/10, negative 0.5. Okay, I notice that I'm shading to the right, which indicates greater than. See how that matches that arrowhead? This time my dot here is filled in or solid, so I have to put the equal sign in there as well. W is greater than or equal to negative 5. All right, there are a couple tricky ones. I want you to write down these 2 sets of phrases. The first one is no more than and at most. Those 2 kind of go together. And the other phrase is no less than and at least. And if you need to pause for a second so you get these written down, go ahead and leave some space here, because we've got to talk about what this translates into as an inequality. No more than. The phrase no more than. Okay. Let's say we're talking about money in your pocket. And if I say to you, or let's say it's me, I have no more than $5 in my pocket. Or I have at most $5 in my pocket. How much money could I have in my pocket? I have no more than $5. Well, could I have exactly $5? Sure, I could have exactly $5. Could I have $6? No, no more than $5. You could have $4, $3 too. I might have nothing in my pocket. Therefore, when you see things like this, no more than or at most, it means you kind of have an upper limit. So that means you have less than or equal to. So when you see that phrase, no more than or at most, it really translates into a less than or equal to symbol. Now, similarly, then if I have no less than, if I have no less than $5 in my pocket, I could have exactly $5, or I could have way more than $5. I could have $10, I could have $20. So if I have no less than $5, I have at least $5. So it's greater than or equal to. All right, set your pencil down, and let's just take a look at some of these situations. All right, because you'll see a lot of word problems, and you have to translate into what that means algebraically. Ray's dad told him not to turn on the air conditioner unless the temperature is at least 85 degrees Fahrenheit. Wow, that's hot. Define a variable and write an inequality for the temperatures at which Ray can turn on the air conditioner. Graph the solutions. All right, I'm talking about temperature. You pick a variable right now, and let's define what it's going to stand for. Now we're talking about temperature, so I'm going to use T. And I'm going to say T is going to represent temperature. Okay? Now, write an inequality that fits this situation. Well, T is my temperature. The temperature has to be at least 85 degrees. T and 80, at least. So it could be equal to 85. And then, can I turn it on at 85? Yes. Can I turn it on at 86? Yes. 87? Yes. but it has to be at least that big or larger. So use greater than or equal to for your inequality symbol. Now, when you go to graph this, I always want you to show me where 0 is, but I don't expect you to start putting 84 hash marks in here to get to 85. That would be crazy. Just simply put another mark here to the right and say, hey, there's 85. It's a positive number. Put my circle there. I look at my inequality. It has to have an equal sign. Shade to the right. Fill in the arrowhead, indicating that anything from 85 on up is a solution. Okay? All right, here's another one. A cell phone plan offers free minutes for no more than 250 minutes per month. Define a variable and write an inequality for the possible number of free minutes and graph the solution. All right, so if it's no more than 250 minutes, and I've got my variable is going to stand for or represent minutes, I think I'm going to be Captain Obvious here and use the variable m for minutes. All right, here we go. M, no more than 250. Okay, no more than means that's kind of like my upper limit. I have to stay under or exactly equal to that amount. Graph the solution. So here's my representation of the inequality. Here's 0. Here's 250, somewhere off to the right. I'm going to put a solid dot here. Color it in because I have the equal sign, and I'm going to start shading to the left. Now, here's where we got to think a little bit. This is a real life situation. Cell phone plan, free minutes. Technically, algebraically, I would normally graph this inequality by going all the way to the left, coloring in the arrow here. But because I'm talking about minutes, am I ever going to get into negative land? No. So in theory, really in this situation, I should probably stop at 0 and not continue on into negative land because it really would not make sense. Okay? So when you get certain word problems, think about it a little bit and say, does it make sense for me to go into negative land? Not really in this situation. I'm going to stop at 0. All right, put your pencils down and let's just talk through some of these, okay? Wrestling is a great one to talk about this because wrestlers are always trying to fit into some sort of weight class as they wrestle. They have to weigh in every single match. A wrestler can weigh no more than 145 pounds. All right, that means if I'm going to use, let's say, W for my weight, W has to stay less than or equal to 145. All right, let's look at another one. Oh, you'll be looking at this soon. In Minnesota, to drive on your own, driver must be at least 16 years of age. So that means, let's see, D for driver, I'll say, and 16, I have to be at least 16, means I could be equal to, but I can't be less than that. I've got to be greater than or equal to 16. And if I were going to graph it, I'd simply say on this one, here's 0, here's 16. I'm going to put a solid dot, shade to the right. Oh, have you ever gone to Valley Fair or to some sort of amusement park and they have some sort of rules or regulations about age? This one says children under the age of 12, under 12 years of old, can ride this ride. So C would be, let's see, under 12. Does that mean you can be 12? Under 12? Technically, the way this is worded, it means if you're 12, you can't ride the ride. You have to be less than 12 years old. You could be 11 years and 364 days, but you can't be 12. So this one would look this way. All right. Oh, gee, I'll be facing this pretty soon. Senior citizens 60 and older get free coffee refills. Oh, awesome. Coffee. 60. But I have to be 60 and older. So I can be equal to 60 or I could be greater than 60. Awesome. Oh, this one happens a lot, doesn't it? You have to do some sort of fundraiser for something. You must sell more than $50 worth of items for the fundraiser. More than $50. So your sales, let's say S is your sales, and it has to be 50 is my significant number, more than, greater than. If you sell exactly 50, is that good enough? Well, according to this one, it says more than 50. So you have to sell $50.01 in order for that to be right. Graphing this one, if it asks you to graph, find 50. This one, you'd have an open circle. Don't color it in. There's no equals part. It has to be greater than. Fill in your arrowhead. Alrighty, there you go. Here's your first assignment on this particular section in Chapter 3. In the textbook, page 171 to 173, you have problems 22 to 33, 38 to 41, 43 to 44. You notice I'm kind of jumping and doing some chunking here with the rest of these. There are a couple challenge ones. You're going to have a lot of graphing, and so when we check it, you have to make sure that you're shading in on the proper side, and then you also have to make sure that you have the shading going the proper way. Watch your circles and so on. Good luck.